This is problem number 6 for section 3.1. In this problem it says find the slope of the graph of the function f of x equals root 2x at 32, a. Then find an equation of the line tangent to the graph at that point. So they want us to find the slope first, then use that to find the line tangent to this line at this point. All right, we're going to start by finding the slope expression. For this function here. And we're going to do that by doing the limit as h approaches 0 of f of x plus h all over minus f of x all over h. So we're going to say that this is going to equal the limit as h approaches 0, and we're going to plug in x plus h into this function. So we get root 2 x plus h minus, this will just be root 2x all over h. Now remember, our goal is to cancel this h out because it's a problem right now. If we're going to evaluate the limit, when we plug it in, we get something undefined. So I think that what we should do is we should multiply by the conjugate to start this. So I'm going to multiply by root, this will be 2x plus h plus root 2x all over root 2x plus h plus root 2x. On top, when we take the limit as h approaches 0, and we take the root here times this root, the roots cancel, I'm left with 2x plus h. I take this root times this one, and I get positive root 2x root 2x plus h. When I take this times this one here, that's minus root 2x root 2x plus h. And finally, I take this root times this one, and it's minus 2x because the roots cancel. So then I'm left on the bottom with, I'm just going to leave these as is because remember I'm trying to cancel h, so this is just going to be root 2x plus h plus root 2x. These in the middle cancel. I'm going to distribute the 2x, or sorry, the 2 to the x and the h, as a limit as h approaches 0 of 2x plus 2h minus 2x all over h root 2x plus h plus root 2x. These cancel, the 2x and the negative 2, the 2x and the negative 2x, so I'm left with limit as h approaches 0 of 2h over h root 2x plus h minus root 2x. The h's cancel, and I'm left with limit as h approaches 0 of 2 over root 2x plus h minus root 2x. Now when I plug in this 0, 0 comes in here, and I'm going to be left with x plus 0 times 2, which would just be 2x on the inside. So I really end up with 2 over root 2x minus, sorry, this should have been a plus. I should have had a plus there. I missed that plus sign. Plus root 2x, which is going to give you 2 over 2 root 2x, which the 2's cancel, and you're left with 1 over root 2x. So that's the expression for the slope for this function here. Now we want to find the slope at 32 comma 8. And in order to do that, we're going to take this function, plug in the x value. So we got 1 over root, this will be 2 times 32. So when we do that, we're going to get 1 over root, this will be 64. And that should give us 1 over, well, root of 64 is 8. So our slope is 1/8. Now we're going to find the tangent line. And to do that, we're going to use slope-intercept form, so 1/8 x plus b. And I'm going to plug in 32 and 8, so I have 8 equals 1/8 times 32 plus b. So I have 8 equals 1/8 of 32 is 4 plus b. I subtract it across, I get 4 equals b. So my tangent line should be y equals 1/8 x plus 4. This is the line that's tangent to this function here at this point.